Welcome to this course again, Machine Learning for All, and we are into the second module where we will be learning more about supervised machine learning. So our first topic is what is supervised machine learning. As already I explained, there will be two types of learning approach, supervised and unsupervised in the machine learning process. And this supervised learning process is mostly common and mostly used where the application is related to prediction or something estimation. So if I go to the formal definition of what is supervised learning, it is nothing but it's an approach where machine learn from the examples or it learns from the real life observations. Basically, you tell it, okay, if these are the patterns and based on this pattern, you should consider this is the outcome. And based on multiple such examples, your machine will learn, and finally for an unknown situation it will try to give the or predict the output or outcome. In the learning process, we need to provide multiple example or the label data, or which is known as training data set, to the machine for accumulating knowledge and decision making for any unknown situations, or for the training data set that you will know in the later stages. Now, if we discuss what is the steps of this supervised machine learning, definitely you have to first gather some data or observation which will help you to train your machine or your model, and then further you have to pre-process the data. So just remember, in the previous module we have learned that the bias inside the data can manipulate your model output, or any misinformation or any kind of errors or any kind of you can say that noise may hamper the performance of your model. So in those cases, to improve the output or outcome from your model, you should definitely pre-process your data. Now this pre-processing may included eliminating missing data where maybe some of the feature values are not available inside that particular data point. Maybe your data is highly biased, so you have to treat it. All those things definitely in the later stages, when we demonstrate some of the models, you will be understanding why they are all necessary. Next stage is nothing but you are splitting the entire data into basically two parts. Two halves, one for your training the data, another part for testing the data. In some of the cases you will find that okay, another process is there known as a validation. So in that case you have to just divide your entire data set into maybe three halves: first training, testing and validation data. After that, once your training data set is available with you, now this data set you use to train your model, which will tune the model parameters to get a robust model, and definitely which will be further used for predicting or estimating some unknown situations in supervised type of machine learning. In supervised machine learning cases or learning process, generally we try to solve two types of problem. One is regression type of problem and another is classification type of problem. In case of regression type of problem, we try to predict the continuous value. Now definitely you may ask what is continuous value. I can give you a simple example. Let's say you have gathered some of the information regarding your past exams, maybe your electric bills. A month-wise you have some electric bill. So these values are nothing but a continuous data. So in those cases, you definitely should go for a regression type of model or regression type of problem you are solving through machine learning problems for prediction. And in another case where I'm just talking about classification type of problem, in those cases you are trying to predict some category or class. Let's say whether I'm going to the college or no, whether I want to purchase a car or I should not purchase a car. All those kind of answer. Maybe you can ask yourself which color of box I definitely need for some work. So color selection where discrete number of colors are available, maybe 3, 4, those cases you should go for classification type of problems. Now, definitely before going for further discussion, we should know about this training and testing process. Now, training process or before that, definitely you have to know how we split it. Now, it is standard that you should keep 70% of your collected data for your training and 30% of your data for testing. And this may vary from 70 to 85. Maybe for some of the cases where your data is very less, you can go beyond till 90%. And rest of the data set you are keeping for your testing activity. Now, also with testing, you have another process that is validation. Validation is nothing but another process of testing where we keep some data for testing or testing your entire model for some tricky or unknown situations and try to average out what is the performance of the data or model. Now, in case of training model, in this process, some instances or a data or known examples are used where already the decision or the outcome value is available with you or best outputs are available with you. And based on this too, you try to teach your machine how to take decisions. And this process is nothing but a continuous process. Let's say right now you have 100 data points or instances where known output or outcome is available with you. Now with time, if this happens that you have more 1000 data points with you, then definitely you can use those 1000 next extra 1000 points to train your model, and this process can continuously improve your model accuracy, and further it can give you kind of a robust model for decision making. So the testing process, in this testing process, what we do, generally the leftover data after training, we use to just compare the output of the model. Let's say already some ground truth is available with you or some known outputs are available with you. Now in the same instances or situations, we try to generate output or outcome, and then this predicted outcome and or model generated outcome is compared with real outcome or the ground truth, and this comparison actually gives you how much this result is deviated from the original or real result, and thus we can really understand how my model is working in different unknown situations, and we can take decision whether we have to continue with the model or we have to train the same model with more data. Next, the validation process. If we talk about validation process, this process is nothing but more similar to testing, but here we try to achieve many more things. At the sense, in the validation process, we try to assess our model ability of generalization and try to find out whether our model is overfitting or not. So we definitely, based on the output or based on the model performance, we can understand whether our model is memorizing those examples or really it is learning from it. And we can easily identify the problems with the model and build confidence or check the reliability of the model in different unknown situations. Some of the method that is very popular for this kind of validation approach is k-fold cross validation and leave one out cross validation. And in case of k-fold cross validation, we try to divide our testing data into 5 k folds or k different segments, and every segments we try to test our data and we try to find out what is the average performance of our model in sub-granularity of the testing data. And leave one out cross validation is nothing but, let's say if you are taking a testing data set where first 4 is used for training and the 5th one is for testing, in this process if you repeat, let's say multiple time, then definitely that process is nothing but leave one out cross validation. So with this 2 approach, we can easily understand whether our model is properly generalizing the output or not, or it is properly learning or not, or it is trying to memorize the particular outcome, or it is biased towards a particular situation or not. So hence, at the summary, I can say that a supervised learning process is nothing but a process where the machine is trying to learn from the previous experiences or from the known real data set, and it tries to mimic the same thing in the real life by estimating the outcome. It may not happen that the result is same every time, but it will try to generate at least similar kind of result. And also we have learned that there are two types of problems that can be solved with a supervised learning. One is regression type of problem, and another is the classification type of problem. And at the end, I can say that the feature or nature of supervised type of learning method is the training and testing, where you have to train your model with some known example, and based on that you have to test that same model in a testing data set and try to find out whether your model is performing well or not. And at the end, I just want to thank all the learners for the next module, and thank you.